So let's look at factors that affect the performance of the computer system. So these are the factors: processor type and number of cores, bus width, clock speed, as well as cache memory. And we'll look in depth on how each factor actually affects the performance of the computer system. So let's start with processor type and number of cores. So first of all, processor can have many cores. So one core is made of an ALU, which is the arithmetic logic unit that we learned in the previous lesson, a CPU, which is the control unit, and the registers. So each core processes one instruction per clock pulse. So you can think of it, one core process one instruction per clock pulse. So per clock pulse, just think of it just like a unit of time. Then more cores means that the sequence of instruction can be split between them. So more sequence of instruction can be carried out simultaneously. And it also means that more cores actually decrease the time taken to complete tasks. So just think of this example. For example, you have a restaurant and then you have like many customers, and initially you only have one waiter to serve all the customers. Definitely the time taken is going to be very long, because let's say this waiter has to serve customer A, then only can serve customer B, C, D, E, and etc. But instead of one waiter, you have like 4 waiters to serve all the customer. It means that at any point of time, you can actually have 4 waiters to serve all the customer simultaneously. So in the end, the time taken to serve each customer definitely will decrease because you have more waiters to serve all the customer. And next, let's look into bus width. So what is bus width? It's actually the number of lines in the bus that determines the number of bits that can be carried on the bus. So for example, an address bus with 8 lines will give numbers from 000000080 here to 11111111 will address 256 different memory locations. So it will allow a larger range of memory locations to be directly accessed. So increasing the width of data bus will definitely increase the number of bits, which is larger word size, transfer at one time, hence allowing transfer of more data each time. And now let's look at clock speed. Clock speed is actually the number of cycles a CPU executes per second, and usually in gigahertz. So for example, 3.5 gigahertz means 3.5 billion clock cycles a second. And each different program instruction has a stated number of clock cycles that it takes to execute that instruction. So you can think of clock cycle just like unit of time. So for example, this program will take 3 clock cycles to complete, and this another program will take 2 clock cycles to complete. So just think of them like a unit of time. And next, if clock speed increases, it means that the execution time for instruction also decreases. That is because you get more flash execute cycles per second. On the other hand, higher clock speed generally means better performance, but it might not always be the case. That is because if the processor doesn't use a wider bus, increasing clock speed alone could lead to problems like overheating and non-synchronization of operations. So in order to improve the performance of the processor, we have to increase the clock speed and the other factors that we mentioned as well. So let's look at one practical example. So for example, we have this processor A and processor B, and this column here indicates time for one clock cycle in microseconds. So for example, processor A takes 2 microseconds to finish one clock cycle, and processor B takes 8 microseconds to finish one clock cycle. So definitely in terms of clock speed, let's think about this. Which processor has a higher clock speed? So the answer definitely will be processor A, because processor A only takes 2 seconds to finish one clock cycle, whereas processor B takes 8 seconds to complete one clock cycle. Just think of it this way: one student takes 2 hours to complete one assignment, and the other student takes 8 hours to complete one assignment. Definitely student A will have a higher speed compared to student B. And let's look at this dummy instruction X here. So this is instruction X, and this is the number of clock cycles required to complete instruction X, and this is execution time in microseconds. So using processor A, we will take 2 times 3, which is 6 microseconds to complete instruction X using processor A. And processor B will take 8 times 3, which is 24 microseconds to complete instruction X. Definitely you can look at this is that processor A is much more powerful compared to processor B because it has a higher clock speed. Therefore, as we say, higher clock speed in general means better performance because the execution time will be lower when we have a higher clock speed. And lastly, let's go into cache memory. So what is cache memory? Cache memory is a small amount of fast memory placed between the processor and primary memory, or placed between the disk and primary memory. And when a processor reads memory, it will first check out the cache and then move on to main memory if the required data is not there. So normally frequently used instruction and data that need to be accessed faster will be stored in the cache memory area of the CPU. So it means that if cache memory size increases, more frequently used instruction can be stored for fast access, and the need for CPU to wait for instruction to be loaded actually reduces. So in the end, CPU executes more cycles per unit time, thus improving performance. So you can think of this way: cache memory is just like a box. Let's say you have this box, and then inside this box which is near to you, you can just store all the instructions that you always use. And when you need to use this instruction, you can just take from this box, and thus reducing the time taken to actually get all this instruction again, and in the end improve the overall performance. So these are the 4 factors that affect the performance of the computer system, such as processor type and number of cores, the bus width, the clock speed, and the cache memory. And if you enjoyed this video, definitely give my video a thumbs up so that more people can see this video, and comment below if you have learned something new from this video. Definitely just subscribe to the channel if you want to learn more about computer science. And if you are taking Cambridge A-Level Computer Science, definitely check out my full online course which covers the latest syllabus at www.hackgrind.school. Thank you, and I'll see you again then. Bye bye.